Welcome to BS350. This is Business Analysis Techniques, and we are in Unit 7 now. And in Unit 7, we are going to continue using Solver. We used Solver last week to help us with a couple of different types of problems. Well, the week before last week we did the comprehensive problems up to that point, but prior to that, week 5, we were working with Solver, and we're going to pick that back up this week, and we're going to use Solver on some more complex problems. And so this is your assignment. I want to help you get started on this. In the week 7 assignment, this is similar to the format we've seen before, where we have the problem information in the blue boxes, and then you're going to complete the problem down below. And so in this problem, it talks about making feed for a nutritional diet for some horses. And we've got some information about the minimum daily requirements that these animals need. And so these are the minimum amounts of specific nutrients that they must have. Then we also have information about the amount of each type of grain or oat or mineral in each type of feed, and then the cost per pound. And so what we're trying to do basically is get a recipe together of how much oat, how much grain, how much minerals we should have so that we can maximize our profit and meet the minimum daily requirements of these nutrients that the animals must have. And so that's what we're doing on this first problem. So we've got constraints here, and I want to point this out. Each ingredient has a minimum daily requirement. So that means we have some constraints. And the first constraint is that we have to have a certain amount of mineral A. We have to have how much of that? At least 6 units. And we have to have a certain amount of mineral B and C. And so each one of these, we have to have a specific amount of that. So our minimum daily requirement is a constraint. And so what you're going to do to solve this problem is you're going to indicate how much A is in each unit of the oat product, of the grain product, and the mineral product, and that minimum requirement needs to be greater than or equal to 6. So that's what you're going to add down here. You're going to just put down in, this is the oats column, mineral A, there's 2 units of A in oats, and 3 units of grain in mineral, 3 units of mineral A in the grain, and 1 unit of mineral A in the mineral product. And so you're going to then sum these. So this is a sum product. This is a similar format. So you'll use the sum product here. And you're going to take in your sum product the number of the amounts that you're going to use of the oats, grain, or minerals times the amount of nutrient A that's in each one of those. And you'll put that there, and this number has to be greater than or equal to 6, because that's what we're told here, right? And then you'll complete this information for each mineral that we have here. And so that way, when you enter your constraints in Solver, you'll have all those different constraints of how much, so that you will have the right minimum amounts of each nutrient in your formula that maximizes. And actually, on this problem, we're not going to maximize profit. We're minimizing costs. Let's look up here. Back. Okay, here we go. Let's look up here. Use Solver to find the optimal daily mix of feed that minimizes total cost. So we're actually trying to minimize cost here. So the formula we're going to have here is going to be the amount of each mineral to use times the cost. Costs are given here. And when we go to Solver, we're going to tell Solver to minimize this field. I think in our previous problems we always were maximizing, but this is a situation where we're going to minimize. So we're going to try to minimize costs. We have the cost per ingredient. We're going to have Solver determine the amounts we should use to minimize costs, subject to these minimum constraints of each type of ingredient. The next problem, let's take a look, has to do with advertising. And what we're looking at is we've got different types of ads that we could have. We could have TV ads, radio, billboard. We've got some constraints. There should be no more than 6 ads from TV and radio. A combination of those should not be more than 6. No ad can be used more than 10 times. The amount spent on billboards and newspapers together can't exceed the amount spent on TV ads. We've got a maximum budget of $14,000. So we've got a few constraints here. What we're trying to do is maximize the reach. We're being told how many people each ad type can reach, and we've got that minimum or that maximum budget of $14,000. So subject to those constraints, we want to reach the highest number of people. Excuse me. So our formula here is going to be a sum product of the number of ads to air of each type times the reach of that type of ad. And we're going to maximize that. Now, so we've got some constraints. You'll have to add these in. But there's TV, radio, billboard, newspaper. I just started adding these in. And you've got some examples in your book. But I want to just show you quickly. Oh, I need to move this over because we want to put a sum product here. We're going to put a sum product here, and the sum product is going to be the number of ads times my entries in the constraint row here. And the reason I have a 1 here is because for each ad that we decide to place for TV, I just want you to multiply that times 1 TV ad. And that way, when I do the sum product here, it's just going to calculate for us the total number of TV ads. Because remember, that has to be less than or equal to 10. So then when we get to radio, we're just going to put 1 under radio, where radio and radio meet. And that way, again, when we do the sum product here, of the number of ads times this constraint row, we'll just end up with the total number of radio ads, which again, the total number of radio ads has to be less than or equal to 10. And so you're going to do that for each of these type of ads, TV, radio, billboard, newspaper. All of those have to be less than or equal to 10. You can't have more than 10 ads of any type. Let me make sure that's what it says. No ad can be used more than 10 times. So there you go. There's another constraint here where it says TV and or radio combined can't be spent on something. Let's look back at the problem. There should be at least, here we go, there should be at least 6 ads on TV or radio or some combination of those two. So TV and radio combined have to be at least 6. So what you can do to make that happen, and again, there's an example of this in the textbook. You'll put a 1 here under TV and radio. So then when you do your sum product here, your constraint is that this number has to be at least 6, so greater than or equal to 6. Then you've got another constraint about billboards. Excuse me. I'm so sorry. Billboards and newspaper together cannot exceed the amount spent on TV. So how will we set that up? Billboards and newspaper cannot be more than TV. So the TV ads cost $800. So what you can do is a little shortcut trick you can do is we're going to put the cost of the TV negative. We want to take off the TV and then add in the cost of the billboards, 500, newspapers, 100. And so what we're trying to do on this row is make sure this amount, the billboards and newspapers combined minus TV, should be less than or equal to 0. And that will tell you that the amount spent on the billboards and newspapers together does not exceed the amount spent on TV ads. If you put in a formula like that, the sum product then is the number of TV, radio, billboards, and newspapers times the cost of these, and this TV ad amount being negative here is going to ensure that it is deducted from the amount spent on billboards and newspapers. And so you'll just tell Excel that this number needs to be less than or equal to 0. So that way you know you're not spending more on billboards and newspapers than you are on TV. Let's see, what other constraints do we have here? The total budget. The total budget has to be less than $14,000. So we also need to put a constraint for that. And so what you'll do is you'll put in the cost of each type of ad, and you'll do your normal sum product, and your constraint is that this number has to be less than or equal to 15,000 or 14,000, whatever the total budget is. So on this one, you're going to have several constraints. So I just kind of put pieces of it in. Once you read the textbook and go through the example, it'll go back through that, but I just wanted to make sure that you know there's going to be multiple constraints to add in here. And if you have questions about this part, just give me a call or email me, or catch me on Blackboard IM. Then real quickly, I just want to look at this last problem just to kind of give you some things to get started. And with this one, you're going to try to, let's see, what do we want to do? We're going to use Solver to find the amount of portfolio that should be in each stock, and we're trying to minimize the risk. So this is another one where we're going to minimize. And so we're going to have our beta here, and we're trying to minimize this beta. We're going to multiply the amount of each stock in the portfolio times the risk of each of those stocks, and that's our sum product formula, and we're going to try to minimize that. And then we've got some constraints, and the constraints are going to be how much of each stock we should have. And let's see, what constraints do we have here? No more than 35% of the portfolio should be invested in any one stock. So that's what our constraint is related to that. None of these 5 stocks should be more than 35%. So the amount should be less than or equal to 35% for the amount of each stock. You're also going to have a constraint related to the proportion. And so you're going to have to enter a constraint that requires that the proportions equal 1. Remember, no particular stock should be more than 35%, but you'll also have to ensure that the total of the proportions equals 1, because this is going to be 100% of the portfolio. Then you'll have to put in a restraint related to the expected returns. Because you have a requirement here. He requires an expected return of at least 11%. So that's our last constraint, is that the returns have to average at least 11%. So that'll help you get started. I know these problems, like I said, are a little more complicated than the solver problems we did before. So if you have questions, feel free to send me your sheet and we can work through it. Catch me on Blackboard IM or email me any questions that you have. This will help you get started, and I look forward to talking to you in the discussion area. Have a great week.